Okay, students, so let's try to understand a theorem today, Thales Theorem, which is also known as Basic Proportionality Theorem, a very important theorem in standard 10th. So let's first read out the statement that is given in the textbook. The statement says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. This is the statement that is given in the textbook, and just by reading the statement you won't understand anything. I know that you don't understand anything by reading the statement, and that's why we are here to watch this video. So let us try to understand brick by brick what does the statement says. So a triangle, first of all they say that a triangle, so let us assume a triangle ADE. Then they are saying that if a line is drawn parallel to one side of a triangle. First we have taken a triangle, and then they are saying to any one side there should be a line drawn parallel to that side. So we will draw a line parallel to DE, and we'll call that line segment as BC. So BC is a line segment which is parallel to one side of a triangle, that is DE. Now what more did they say? They said that two distinct points. Which are the two distinct points? The points are B and C. The point B is lying on side AD, and the point C is lying on the side AE. So what do these two distinct points do? They divide the sides in the same ratio. So B is dividing the side AD in the same ratio as C is dividing the side AE. That means AB upon BD is equal to AC upon CE. So this is what the statement is all about. We have been given that BC is parallel to DE, and we have to prove that AB upon BD is equal to AC upon CE. This is what we have to prove. Now let's try to understand how do we prove this? How do we prove the Thales Theorem? So in order to prove, let us assume two triangles, one green color and other red color, both having same bases. I have taken both the bases as BC because they both have equal bases. So both the triangle have base BC, one is triangle DBC, another is triangle EBC. Now if I'll draw a line L which is parallel to BC and going through the points D and E, then what do I get? I get that if there are any two lines parallel to each other, then the perpendicular distance between them will be equal. So between the line L and BC, the perpendicular distance at any point will be equal. So I'll draw two perpendiculars, one for the red and another for the green triangle. For the red I'll draw DM, okay, which is a perpendicular, and for the green triangle I'm going to draw a perpendicular EN. So what do we get? We get that DM is equal to EN, because between the two parallel lines the perpendicular distance is always equal. So DM is equal to EN, and BC was always equal to BC. So what do we understand from these two triangles? That they have equal areas. If in any two triangles they have same base and same height, then their areas are equal. So by going through all this, what we have finally proved is that area of triangle DBC is equal to area of triangle EBC. Why is that so? Because both of them have same base and same height. Now what do we do? Now we will take this a little step forward. We will overlap these two triangles. Both the triangles have same base BC. So I'll place BC over BC. So it will look like this. You can see both your triangles. One is your red one, another is your green one, and both have the common base BC. So I've kept one triangle over the other. And then I'm just going to flip it. Just flipping it, what will happen? Flip it means I'll take it upside down. So BC will go up and DE will come down. Okay, so we can clearly see both our triangles DBC and EBC both are lying on the same base BC, and yes, what did we prove? that the areas of these two triangles are equal. So we'll write it down that the area of triangle DBC is equal to area of triangle EBC. Now what do? We need one more triangle. So we are going to bring in one more triangle and place it right above BC. And let's call it a blue triangle. So I'm going to bring a blue triangle and keep it right over BC, and I'm going to call this triangle as ABC. Now what do we do with this blue triangle? We will divide both the sides by the area of this blue triangle ABC. So we already have area of triangle DBC is equal to area of triangle EBC. Now I will divide both the sides by area of triangle ABC. You can do that. You remember that if you divide two equals by an equal number, the result is always equal. So I can divide both the sides by area of triangle ABC. So now this is what I finally get. Area of triangle DBC upon area of triangle ABC is equal to area of triangle EBC upon area of triangle ABC. I have divided the area of triangle ABC on both the sides. Now we are very close to proving a theorem. All we have to do is just use the formula of area of triangle, which is half into base into height. So for area of triangle DBC, what will be your base? Half into base. You need a base. So you will take your base as DB. So if you take your base as DB, your height will be CM. Quite interesting that the height is outside the triangle. But yes, because DBC is an obtuse angle triangle, and that's why the height is outside. So if you take the base as DB, you have to take the height as CM. Now what about area of triangle ABC? You will take the base as AB and the height will be same, CM. We are trying that the height of both the triangles are same so that they get cut off, and the bases are different. For the red triangle, we took the base as DB, and for the blue triangle, we took the base as AB. So we'll take different bases but same height. Now let us solve on the right hand side. On the right hand side, we have area of triangle EBC. So for EBC, the base that I'll take is EC. And obviously, if I take base as EC, my height is going to be outside, which is nothing but BN. So I'll write half into CE into BN upon area of triangle ABC, same height, BN, and base will be AC. All I'm trying to do is keep the base different and the height same so that all gets cut off, and what we are left now is with DB upon AB is equal to CE upon AC. But wait a second, is that what we are supposed to prove? No, I think we have done it the inverse of what we were supposed to prove. Not an issue. If we have proved DB upon AB is equal to CE upon AC, we can use a small property which is called invertendo. If I use that property called invertendo, we can just inverse this proportion. So what it will become now? After using invertendo, it is going to become AB upon DB is equal to AC upon CE. And that was what we were supposed to prove. So see guys, it was so easy to prove by this way, and I hope you have understood. I hope if you like the video, you can press the like button, you can subscribe to my channel, and leave some comments if you want a video on a particular concept. Till then, take care, stay home, stay safe. Goodbye. Thank you very much.